For question 7, the answer is actually C, because you can see that the abundance for copper 63 is twice the abundance for copper 65. So basically what it means is that the AR for the copper would be closer to 63, okay, which the question says is 63.6. So this is the most likely answer. Now D cannot be the answer because there are 4 isotopes. Okay, so for 3, the isotope with a higher abundance, the AR would be closer to this particular isotope. Just like for example over here. Okay, the chlorine 35 has a higher abundance, right? 75%. And chlorine 37, lower abundance. That is why the AR for Cl is 35.5. It's always closer to the isotope with a higher abundance. So since copper 63 has a higher abundance, so the AR for copper will be closer to 63. So 63.6 is actually closer. It's actually close to 63. Okay, so the best answer is C. Now let's look at question 8. What happens when potassium chloride melts? So potassium chloride consists of potassium ion as well as chloride ion. So when they melt, the potassium ion would be separated from the chloride ion. But first of all, how do you separate them? That is, the electrostatic attraction forces will be overcome. So electrostatic forces of attraction between oppositely charged ions are overcome when you melt them. So the answer is C. Okay, now let's look at question 9. A stable molecule containing atoms of the elements X, Y, and Z has the following structure. So which row shows the identities of elements X, Y, and Z? So just remember all this line. One line means what? One line means one covalent bond. All these are covalent bond. One line means one covalent bond. One covalent bond means share one pair of electron. Share one pair of electron. Now, why does the atom need to share one pair of electron? Because it is short of one electron. Short of one electron. That's why I need to share one pair. Now, when the atom is short of one electron, that means it should have 7 valence electron. Okay? So, when you see that, for example, Z, one line, right? So, which means that it has 7 valence electron. So Z must have 7 valence electron, meaning that Z must be fluorine, cannot be sodium, cannot be phosphorus. So it's either B or C. Then you look at X. X share 3 pairs of electron. X share 3 pairs of electron, 3 lines, right? Share 3 pairs of electron, meaning that short of 3 electrons, meaning that it has 5. X are actually 4 pairs. X 4 pairs. So share 4 pairs of electrons, short of 4 electrons, meaning that it should have 4 valence electron. X should have 4 valence electron. So if you look at the choices, it must be silicon. Okay, cannot be phosphorus. Phosphorus is group 5. So silicon. So the answer is C. So you don't even need to look at Y. Just look at X and Z. Question 10. Okay, properties. Which row shows the identity of P, Q, R, and S? P, Q, R, and S. Okay, the answer is A. Now, if you look at A, methane, low boiling and melting point, doesn't conduct electricity because methane is a covalent compound. It's a covalent compound. And what is the formula for methane? CH4. Okay? So all these properties here, covalent compound has low boiling and melting point, doesn't conduct electricity. Now silicon dioxide is a giant molecule, high boiling and melting point. This one doesn't conduct electricity. And then rubidium is a group 1 metal. It has low boiling and melting point, and then electrical conductivity. It does conduct electricity because this one is a metal. All metals conduct electricity. And then graphite, yes. So the answer is A for number 10. Okay, number 11. 2 of the reaction of the manufacture of nitric acid are shown. What is the maximum number of moles of nitric acid that can be produced from 1 mole of nitrogen monoxide? 1 mole of nitrogen monoxide. So this is nitrogen monoxide here. 2 mole of nitrogen monoxide produces 2 mole of nitrogen dioxide, which means that if I have 1 mole here, I would produce 1 mole of nitrogen dioxide. Now 4 mole of nitrogen dioxide produces 4 mole of nitric acid. So if I have 1 mole of nitrogen dioxide, I would produce 1 mole of nitric acid. So the answer is B. Alright. Number 12. 3.55 gram sample of an oxide of phosphorus was found to contain 2 gram of oxygen. So what is the empirical formula of this oxide? So basically you need to find out what is the mole of your phosphorus and what is the mole of your oxygen. You just have to find out the mole ratio. You have 2 gram, right? You have to change it to mole. 2 over 16. Have to find out. And then you have 3.55 gram sample of an oxide. So what would be the mass of phosphorus? That would be 3.55 minus 2. That would give you 1.55. And then this 1.55, how many mole it is? Okay, you have 31, so you have to find out the ratio. 0.125 0.05. Okay, 0.125 0.05. So what you can do is which one is smaller? 0.125 is smaller, right? So divide by itself. So this is 1. How about this one? Divide by 0.05. 0.125 divided by 0.05. That would give you 2.5. See, the ratio is 1 to 2.5. So this 2.5 you can times 2, which is 5. 1 you can times 2, which is 2. So it's 2 is to 5. It's P2O5. The answer is D. P2O5. Alright? So that would be the empirical formula. Now let's look at question 13. Sodium azide. Okay, sodium azide is used in airbags in the car. When there is serious collision, the sodium azide will decompose into its element. Decompose into its element.